VLAN switches, specifically managed switches, are the foundational hardware that makes virtual local area networks possible. They act as intelligent traffic controllers that can logically partition a single physical switch into multiple independent mini-switches, each functioning as a separate broadcast domain. Core concepts of VLAN switches: logical segmentation. The primary concept is that a single physical device can enforce layer 2, data link layer, separation between groups of ports, regardless of their physical location on the switch. For example, ports 1 to 4 might be configured for a finance VLAN, and ports 5 to 8 for a guest VLAN. These two groups cannot communicate directly, just as if they were connected to two entirely separate physical switches. VLAN awareness, management. A switch must be VLAN aware, a managed or smart switch, to use VLANs. Unmanaged, basic switches are plug and play and simply forward all traffic within a single default network, usually VLAN 1. Managed switches provide a management interface, web GUI or command line interface, that allows administrators to define VLANs, assign ports to specific VLANs, and configure how traffic is handled. Port assignment, access versus trunk. VLAN switches use different port modes to manage traffic. Access ports, these ports connect to end-user devices, computers, printers, IP phones, that are typically VLAN unaware. Traffic entering or leaving an access port is untagged and belongs to only a single, specific VLAN configured by the administrator. Trunk ports, these ports are used to link two VLAN-aware devices, such as switch-to-switch or switch-to-router connections. A trunk port can carry traffic for multiple VLANs simultaneously by adding an 802.1q tag to each frame, identifying which VLAN it belongs to. How they work: when a frame, a data packet, arrives at a switch port, the switch determines its VLAN membership based on its configuration. 1. Ingress, incoming. If the frame arrives on an access port, the switch assigns it the port's predefined VLAN ID. If it arrives on a trunk port and is tagged, the switch reads the existing VLAN ID in the 802.1q header. 2. Forwarding decision, the switch uses its internal MAC address table, which includes the VLAN ID, to decide which port to forward the frame out of. Crucially, the switch will only forward the frame out of ports belonging to the same VLAN, thereby containing broadcast traffic within its intended logical boundary. 3. Egress, outgoing. If the frame exits an access port, the switch removes the VLAN tag before sending it to the end device, which is unaware of the VLAN system. If the frame exits a trunk port, the tag remains intact, or is added, in the case of the native VLAN, so the receiving switch can process it correctly. In essence, the VLAN switch is the enforcement point for network segmentation, using its configuration and the 802.1q tagging standard to manage traffic flow efficiently and securely across the physical network infrastructure. VLAN membership. VLAN membership can be determined using a few methods, broadly categorized as static and dynamic. The choice of method depends on network size, security needs, and device mobility requirements. 1. Static VLAN assignment, port-based VLANs. This is the most common, simplest, and widely used method for assigning VLAN membership. Concept: the network administrator manually assigns specific physical switch ports to a particular VLAN ID, VID. Any device that plugs into that configured port automatically becomes a member of that VLAN. Pros: it is straightforward to configure, manage, and troubleshoot. It provides a high level of security because access is controlled by the physical port. Cons: it lacks flexibility. If a user moves their device to a different port, or location, the network administrator must manually reconfigure the new port to the correct VLAN. Usage: ideal for smaller networks, areas where devices remain in fixed locations, and environments needing strict control over access points. 2. Dynamic VLAN assignment. Dynamic VLAN assignment uses software and databases to automatically assign devices to a VLAN, offering greater flexibility and mobility. This approach is generally less common due to complexity and the need for specialized server software. A MAC address-based VLAN assignment concept. VLAN membership is determined by the device's unique physical media access control, MAC, address. The switch checks a centralized database, often maintained by a VLAN management policy server, VMPS, that maps MAC addresses to specific VLAN IDs. Pros: this method provides mobility. Users can move their devices to any port on any switch in the network, and the switch will automatically assign the correct VLAN, with no need for manual reconfiguration. Cons: initial configuration is complex, requiring all MAC addresses to be mapped in the central database. This method may also require higher-end, more costly networking equipment. Usage: suitable for large enterprise networks with a high degree of user or device mobility, such as a large office with shared desks, hoteling. B. Protocol-based VLAN assignment concept. VLAN membership is determined by the type of network protocol being used within the frame, example IP, IPX, AppleTalk. The switch inspects the ether type field in the frame header to make a forwarding decision. Pros: allows administrators to separate different types of network traffic into different broadcast domains regardless of the physical port or MAC address. Cons: less commonly used today as most modern networks are predominantly IP-based. It offers less granular control than port or MAC-based methods. Usage: useful in multi-protocol legacy environments to optimize traffic management. 3. Authentication-based, 802.1x/radius, while sometimes grouped under dynamic VLANs, this is a modern, highly secure method using network authentication protocols. Concept: when a device connects to a port, the switch doesn't immediately assign a VLAN. Instead, it holds the traffic and initiates an authentication process, example using 802.1x and credentials, with a central authentication server, typically a radius server, like Cisco ISE. The radius server verifies the user/device credentials and then informs the switch which specific VLAN ID the port should use for that authenticated session. Usage: widely used in secure enterprise networks and wireless networks to provide secure, dynamic VLAN assignment for authenticated users and devices, ensuring consistent access policies across the entire infrastructure. VLAN switches between vendors: VLAN switches from different vendors can be used together in the same network, provided they are managed switches that all adhere to the industry standard IEEE 802.1q protocol. Interoperability is possible because the core function of VLAN tagging is based on an open standard. However, mixing vendors does come with a few important considerations. Key interoperability considerations: standard protocols are essential, stick strictly to industry standard protocols. VLAN tagging: ensure all switches use the 802.1q encapsulation method for communication between switches, trunk links. Avoid proprietary protocols like Cisco's legacy InterSwitch Link, ISL, as it is not supported by other vendors. Spanning tree protocol, STP spanning tree is crucial for preventing network loops. There are different versions of STP, RSTP, MSTP. Ensure all switches across the network are using the same version, preferably a standards-based one, like MSTP or RSTP, as some vendor-specific versions like Cisco's PVST Plus may not interoperate well with others. Link aggregation, LACP for combining multiple physical links into one logical link, use the standard link aggregation control protocol, LACP, which is universally supported. Configuration terminology differences: this is the most common hurdle. Different vendors use different terminology and command line interfaces, CLIs, to achieve the same result. Cisco often uses the term trunk port for a link carrying multiple tagged VLANs and access port for an untagged end-user port. HP/Aruba often uses tagged for a port that carries 802.1q frames, trunking, and untagged for an access port. You must ensure these configuration settings match on both sides of the link connecting the two different brand switches. Native VLAN configuration: the native VLAN, the VLAN whose traffic is sent untagged over a trunk link, must be consistently configured on both sides of a cross-vendor trunk connection. Increased administrative burden: while technically feasible, mixing vendors means managing different interfaces, command syntaxes, and support contracts. It generally makes network management more complex than using a single vendor. In summary, mixing VLAN switches is possible and functional if you rely on open standards and ensure configurations are precisely mirrored between devices. Cisco's approach to VLANs has a history involving both proprietary and standards-based technologies. While Cisco was an early innovator in the VLAN space, they later adopted and now primarily use the open standard for interoperability. History of Cisco's VLAN implementation: Cisco's history with VLANs can be divided into two key phases. Phase 1, the proprietary era, InterSwitch Link, ISL. In the early days of networking, before a universal standard existed for VLAN trunking, Cisco developed its own proprietary protocol called InterSwitch Link, ISL, to carry multiple VLANs over a single link, a trunk. Proprietary nature: ISL was a Cisco-only protocol, meaning it only worked between Cisco switches or between Cisco switches and routers. It could not interoperate with switches from other vendors. Encapsulation method: ISL used an external tagging method, encapsulating the entire original Ethernet frame with a new 26-byte header and a 4-byte trailer, making the total frame size larger than standard Ethernet frames. This was different from how the later standard would implement tagging. VLAN trunking protocol, VTP. Cisco also developed the proprietary VLAN trunking protocol, VTP, to automatically synchronize VLAN configurations across all Cisco switches in a network, reducing administrative overhead. VTP is still a Cisco proprietary technology. Phase 2, adopting the industry standard, IEEE 802.1q. As networking evolved, the Institute of Electrical and Electronics Engineers, IEEE, developed and released the open standard for VLAN tagging, IEEE 802.1q, around 1998. Open standard, 802.1q was designed to provide multi-vendor VLAN support, allowing switches from different manufacturers to communicate using a shared protocol. Tagging method: unlike ISL's encapsulation, 802.1q uses an internal tagging mechanism that inserts a smaller, 4-byte tag inside the original Ethernet frame header. This makes it more efficient and compatible with standard Ethernet hardware. Cisco's transition: Cisco adopted 802.1q to ensure interoperability with other vendors. Modern Cisco switches primarily use 802.1q by default, and ISL is largely obsolete and not supported on many newer Cisco platforms. Current status: Cisco's VLAN implementation is no longer strictly proprietary. Cisco switches use the industry standard IEEE 802.1q protocol for trunking between devices. This allows Cisco gear to seamlessly interoperate with non-Cisco equipment. However, specific management features like the VLAN trunking protocol, VTP, and dynamic trunking protocol, DTP, remain Cisco proprietary. In short, the fundamental way VLANs work on modern Cisco equipment adheres to open standards, but certain automation and management protocols developed historically by Cisco remain proprietary to their ecosystem.